Hi, welcome back. So in this video, we are going to discuss Wilcoxon rank sum test for independent samples. So the general idea behind this test is that you assign the ranks to each value in two subsamples, while the ranks are calculated as for two samples being combined. Test statistic is calculated as rank sum for a smaller sample. This is important. And there are two assumptions to be fulfilled. So first of all, two samples should be random and independent. So this means that you should use proper sampling method and they should be independent. So here the notion of independence is very similar to what we discussed last time for T-student test. So no group should affect the other group. Respondents from one group cannot be in the second group as well. No value from one group should affect any value from the second group. And second, two probability distributions from which the samples are drawn are assumed to be continuous. So let us analyze the test based on the following problem. So, during the experiment, two samples of potential consumers were examined. The respondents were asked to propose a price for the mascara. In the first group, the respondents were provided information about the market price of a similar mascara. And we have to test the hypothesis that respondents from the first sample are willing to pay more than respondents from the second sample. And we assume that alpha is equal to 0.025. So you can figure out that the test we are going to perform is not two-tailed, it is one-tailed test. And this is how we formulate the relevant research hypothesis. So the null hypothesis states that the probability distributions corresponding to the willingness to pay among the respondents from the first and the second sample are identical. And the alternative hypothesis states that the probability distribution for the first sample respondents' willingness to pay lies above or to the right of the probability distribution for second sample respondents' willingness to pay. And before we proceed to computing test statistic, let us first figure out what rank stands for. In general, rank is a position in the hierarchy. And as I told you at the beginning of this lecture, for Wilcoxon rank sum test, you have to assign ranks to each observation as for a part of the big sample consisting of two samples combined. So I put all the values for the first sample and the second sample in one column, and then I figure out the rank. For instance, there are 9 observations. 2.1 is the lowest offered price. That's why I assign rank 1. 6.8 is the highest one. That's why I assign rank 9. 5.5 is the second largest, so I assign rank 8, and so on and so forth. So the idea here is pretty intuitive, and once you figure out those ranks, you can just put them to the table for the first and the second sample to calculate them separately. So here, for the first sample, sum of ranks is equal to 23, and for the second sample, sum of ranks is equal to 22. By the way, when it comes to the total sum of ranks, it can be calculated based on the number of observations. So in our case, we have 9 observations in total. So according to this formula, the sum of ranks in the first and the second sample should be equal to 45. And yeah, this is what we can see here. A little of mathematic magic. The next step is detecting the critical values. So for this, you actually have a special table for Wilcoxon rank sum test. So in the first sample, we have 5 observations. In the second sample, we have 4 observations. So those are our critical values. Everything between them goes to the region of acceptance. Everything to the right and to the left goes to the region of rejection. So this time we are specifically interested in one-tailed test. That's why for us the critical value is 28. Okay, so as discussed before, when it comes to test statistics, this is always rank sum for a smaller sample. In our case, the second sample is smaller, so t is equal to 22, and we actually failed to reject the null hypothesis because test statistic is not bigger than the critical value. So, yeah, we failed to reject the hypothesis that respondents from the first sample are willing to pay more than respondents from the second sample. So that was it. In the next video, we are going to discuss Wilcoxon rank sum test for pair differences. Thank you for watching and see you in the next video.